Let's be honest, as powerful as modern AI feels, it also has a few pain points of its own. One of them is how the data these models learn from can be quietly tampered with. A new study from Anthropic, working with the Alan Turing Institute and the UK AI Security Institute, just showed how surprisingly easy that tampering can be. So today, we're breaking down exactly what they found, what data poisoning looks like in the real world, and how you can stay ahead of it before it becomes your problem. Let's start with the headline. The Anthropic team ran experiments and found that injecting as few as 250 malicious training documents into a model's dataset was enough to introduce a backdoor vulnerability regardless of how large the model was. To be clear, we're talking about models ranging up to 13 billion parameters, big models trained on massive datasets. Yet this tiny number of poisoned docs still worked. That flips one of our major assumptions on its head. We used to think that if an adversary wanted to mess with the model, they'd have to control a large percentage of its training data. But the key takeaway here is that scale alone doesn't guarantee safety. A mere 250 docs in a dataset of billions is negligible, but that's all it took in its test. So why is it so important? Because it means threats we assumed were theoretical might be much more practical than we thought. The attack surface for AI is broader than just someone wrote a bad prompt. Alright, now that we've seen how a poisoning attack can look, let's break down what data poisoning actually is and how it happens. In essence, data poisoning occurs when someone injects corrupted, misleading, or manipulated data into the dataset used to train or fine-tune AI or machine learning models. You'll find a few flavors of poison out there, including label flipping, where correct labels and training data are swapped so the model learned wrong mappings. Data injection, during which entirely fabricated samples are inserted to steer the model's behavior. And backdoor attacks, where subtle trigger phrases or patterns are embedded so that when a certain input appears, the model behaves in a controlled way. Think of it like teaching someone how to drive by showing them a mix of real road signs and fake ones, but only the fake ones appear when they're at a specific intersection. Suddenly, they do something unexpected. And it's not just academic. When models are trained on scrapped web data, crowdsourced data, or data sets with limited provenance, attackers may find opportunities to hide poisoned content. Even a few malicious entries can shift outcomes. That's the vulnerability. And that vulnerability doesn't stay theoretical once AI enters actual workflows. So what's the big deal? Why should you care even if you're not building your own model in a lab? Because AI is rapidly becoming part of how businesses operate, how decisions are made, and how recommendations are generated, everything hinges on one assumption, that the model actually learns from clean, trustworthy data. When the foundation cracks, the entire system starts to wobble. For example, poisoned training data can cause models to misclassify things they previously handled with ease. These subtle performance dips often go unnoticed until they affect something important. Even small disturbances in the data can lead to models making wrong calls in situations where accuracy used to be reliable. Things can also veer into the more consequential territory. Poisoned samples can skew how a model treats certain groups or inputs, quietly introducing bias that changes downstream decisions. And then there are backdoor vulnerabilities, hidden triggers embedded in the data that can be exploited later. Anthropic's study demonstrated this with what looked like harmless gibberish triggers, but the real message was clear. If nonsense can open a backdoor, more dangerous behaviors could too. All of this lands in a business environment where leaders already feel the pressure. According to a recent survey by IBM, 82% of executives say securing AI is important, but only 24% are actually doing something about it. That gap between awareness and action leaves a lot of organizations exposed without realizing it. So the bottom line is simple. The risk is real, it's growing, and in many cases, companies may already be more vulnerable than they think. How to mitigate these risks? Alright, we've covered the problem and why it matters. Now let's shift into what you can actually do about it. This is where theory turns into real, practical defense, the steps that help you reduce your exposure and strengthen the AI applications you rely on. First, data validation and sanitization. Make sure before you feed data into a model that it's been checked. Look for anomalies, unknown sources, odd formatting, or trigger-like patterns. This builds a solid foundation. Second, adversarial training and robustness techniques. By deliberately introducing challenging cases or potential poisons during training or fine-tuning, you can make the model tougher. Third, continuous monitoring and anomaly detection post-deployment. Watch for unusual behavior shifts, unexpected outputs, or triggers. If the model's performance drops or changes in unusual ways, investigate. Fourth, strong data governance and access controls. Restrict which datasets can be used, who can modify them, maintain maintain logs of training data changes, and use provenance where possible. Attackers often exploit weak pipelines or unverified data sources. Finally, layered defense mindset. No single control is enough. Poisoning is one threat among many. Building in multiple safeguards gives you resilience. If there's one thing to take away, it's this. Data poisoning isn't just a research problem. It's a practical, everyday risk that grows as AI becomes woven into more of our work. The Anthropic findings are a wake-up call, but they also give a roadmap showing exactly where to look and what to fix. As you start thinking about your own AI workflows or the tools your team depend on, ask yourself whether the data pipeline is as trustworthy as the outputs you expect. If not, this is the time to strengthen it. Stay curious, stay critical, and keep your guard up when it comes to the data your models learn from. And if you want help building your skill set and strengthening your knowledge surrounding data, check out the links in the description for some sources to help you get started. Thanks for watching, and I'll see you next time.